Let's take a look at the general structure of this TG51 equation here. So in this equation, D is the absorbed dose in water. M is the reading in the ion chamber. It is a value that we measure in the water tank. KQ is called beam quality factor. It comes from partly from measurement and partly from calculation using the TG51 report. KQ is called beam quality factor because it closely relates to the beam quality. So for example, KQ for photon beam is closely related to the percentage depth dose value at depth of 10, right here. KQ for electron beam is slightly more complicated than photon beam. It can be further break down into three factors: the P gradient, the KR50 prime, and the K ecal. Each factor comes from the water tank TG51 measurement and also requires some calculations from the TG51 report. I will discuss KQ more and its subfactors more in the next video lectures. One should notice that KQ factor has no unit. And this NDW cobalt 60 is a factor that comes with a calibrated ion chamber. So basically every 2 years we send our ion chamber to National Calibration Lab, ADCL, to calibrate the chamber. The calibration is all about obtaining this NDW cobalt 60 factor. So this value does not come from our annual TG51 measurement, and different chamber has different NDW value. This NDW cobalt 60 factor has the unit of centigrade per nanocoulomb or centigrade per coulomb. For example, in our clinic, we use the PTW semi-flexed chamber, which has a 0.3 cc volume. It has a calibration factor of 9.356 multiplied to the 10 to the 9th centigrade per coulomb. And as you can see, we calibrated the chamber almost 2 years ago. And this value, because it comes from the chamber, is the same for both photon and electron beam. Let's review the equation one more time. We know that NDW cobalt 60 factor is in the unit of centigrade per nanocoulomb, and our chamber reading, M, is in the unit of nanocoulomb. And KQ has no unit. So when we multiply together, the nanocoulomb cancel out. It leaves the centigrade, which is the unit of absorbed dose in water, the unit of D right here. And because we know we deliver 100 MU for this absorbed dose in water, so we use this value to divide it 100 MU, we will have the LINX output in centigrade per MU. This is basically how we obtain the LINX output using the TG51 recipe. In the next few video lectures, I will use example calculations to explain detailed measurements and calculations for both photon and electron beams.